Everyone, welcome back to my channel. Today I am going to start a new series for Python where I am going to cover the entire Python, how to use a Python's, do programming in Python's, a complete series from beginners to expert. So let's get started. So first of all, let me show you what we are going to cover in our sessions. So the first we are going to understand how we're going to set up this entire environment for Python and what kind of IDs we can use. We have options into that. Second, we understand the variables in Python. Again, after that we use data types to understand what what are the data types we have in Python and how we can use it. Understand the operators, the data structures, flow control, and after that we'll understand in detail the oops concept in Python. And last but not least, we are going to see the libraries we use, libraries like NumPy, Pandas, Matplotlib for numeric calculations, data manipulations, how these going to be used in a data science and all. So this is the overall content which we are going to cover in this series. So let's get started, and first we install it. So before installing it, we have to install the Python. So this is my link for Python. Let me open this. So this is the page, the python.org/downloads. So you can see this is the page where you can download your Python. So it's depend on what machine you are using. If you are using a Windows, there's an option to Windows. You can download it from over here. You can see there are Python releases available. So latest one is a 3.9.6 for Python 3, which I'm going to use it. If you have a Mac OS, there's an option for Mac OS also, so you can download from over here. I am not downloading it because I've already installed in my system. So that's why I'm showing you that if you click on this, it will give you to download, and you can download over here. Now the second thing is, so while doing a programming and all, we require a ID. Like if you aware of the programming, then you know that we are using different IDs for working it. Like for Java we used Eclipse, IntelliJ. These are the IDs which use for programming into Java and other languages also. So for the same we required a ID for working on the Python. So we have two IDs. One is a PyCharm and one is an Anaconda. So let's talk about first PyCharm. So it's a JetBrains ID, created ID. So over here in this page, this is a download. Click on the download. You can find all these links into the description box. We have to download the community version, so you have to just click on community. If you have a Windows machine, you will redirect on the Windows and you can download directly from over here. In the Mac OS or a Linux, depend on your machine, you can download over here. So this is the PyCharm which we can use as an ID for working on the Python programming language. The next one is the Anaconda. Let me open this Anaconda. So this is another ID which is basically distribution system, you can platform, you can say, because it's provide you all the libraries which we have. If you go over and you can see, it's provide 7,500 data science and machine learning packages. So it's kind of a huge library, and also support the R packages also. So this is the one which we are going to use it into that. You can download and install it on your machine. So now, Anaconda basically provide a notebook interface, a web-based interpreter, which we are going to use, and that's called a Jupyter notebook. Let me show you. This is a Jupyter notebook, which is a web-based interpreter, which we are going to use it. So let's get started. So this is how we are going to install our environment. let me launch Anaconda. So basically for Mac OS, there's only one interface which is called Anaconda Navigator. But in case of Windows OS, there are two interface provided. One is a GUI and another is a prompt base, which is called as the Anaconda root. So mostly for the programming language, we use a GUI interface. But if you like to do programming that you can into the command prompt, you can use Anaconda root. So over here, this is the Anaconda Navigator, and these are the applications which are we can use it. So we are going to use Jupyter. Let me launch it. Let's launch it. So this is the interface look like for Jupyter. And click on new, you can see the notebook is a Python 3 because we are using a Python 3 version. So I am going to click on this Python 3. So there are you can see these are the cells which where we are going to write our code over here, and these are the different menus which you can see over here, which is pretty standard and given descriptions over here to work on it. Like you can see, the kernel is basically responsible to execute your code over here. So these are the different options which we can use on the work on the kernel side. Yep. So let's start it. So now the next thing which we are going to study is the variables. Basically, variables are simple in a simple terms is a temporary storage to store the values. So each and every variable consists of three things. One is the name of the variable. Second, memory address in the memory. Third is the value which is going to be stored in the temporary. So this is the example which I have given over here. Is a variable like if I give a variable, so where is my variable, I have given variable, it will print the value of my where, and the I can change it over here. So let's see how it's doing in the programming. Okay, so let me define a variable called test. I'm giving the value of 10 over here. I'm going to run it. You can see the value. Now if I'm going to change the value in a string, now you can see my value is hello printed over here in the same variable. So in this way, the variable works in the Python itself. Now if I have to add the new cell, I have to just click on the add cell. My add cell is added over here. Now the next thing which we are going to understand is the data types. So basically Python have a 5 types of data types: integer, float, boolean, string, complex. So we are going to see one by each of them and see the examples over here. So let's talk about the first. So my variables is x, and I'm giving value of x, and if I print it, it will give me a value of x. Now if my value is x equal to 2.45 and I give the value of x, and this give me a 2.45. If I, let's suppose if I give a value of x equal to true and print it out, it will give me a value of true, right? And let's say if I say type of x and run it, it will be a boolean value. In the same way, if I say x equal to 3.12 and type x over here and run it, it will give me the data type of float. In the same way, we can, if I change the value as a string, x equal to hello world type x, it will give me a value of a string str. So basically it's, we not define which kind of a variable it is. It will take, it will consider as a based on the reference value which we are giving to the variable. So in this case I am giving a value as a string, so it will see the reference value and consider as a string data type. So this is the way we are defining or using the data types and the variables in the Python. So let's move ahead and we'll see the next one in our topic, which is the operator. So there are three kind of operators in Python: arithmetic operations, operators, relational operators, and the logical operators. So we'll go and see each and every operator over here. So let's start with arithmetic operators. So let me create a new notebook. I have created just like a new notebook over here. I'm going to use it, leave on this page. Yeah. So let me define a value of x equal to 20 and y equal to 30. Let's say 10. This is my value I have defined it. Now use arithmetic operator. So arithmetic operators, I'm going to write x plus y and going to run it. I can see the arithmetic has been done, x plus y over here. See basically like in other languages, if we required a comment, the value, comment or any statement, so we are using a hash to comment any statement into the Python language. But if case if I run this in this way, arithmetic operator, it won't understand. Like if I run it, it will give me a syntax error, invalid syntax. So in this way it's work as a if you have to do comment any value or comment any statement, we are going to use hash into that. Now let's talk about the another arithmetic operator. Let me say I have value x and y. So x minus y, this is 10. If I say x divided by y and run it, it will give me a 2.2, the value of this. And if I say multiplication of this, so x multiply y, and if I say it's give me a value of 200. So this is the way the arithmetic operators work. Let's see the operators. The next operators are relational operators. So these are the values. So let's talk about the in the same way. I have a value of x and y. So if I say x is less than y and run it, it will give me a false because my x value is greater than y. So this is the false. But in case if I say x is greater than y, sorry, my bad. If I say x greater than y and run, I can see the true. And if in case I use x equal to y and see false because both of them values are not equal to each others. If I say, if I use not equal, which is called y, x not equal to y, this is a true value. So in this way we are going to, this is how the relational operators will work. Now let's talk about the value, the variables are the logical operator. So basically logical operators are like, if one value is my true and the another value is true, then we if we are going to use and, it will show the AND value. So basically it would be in this way. These are my operators, right? Now let's talk about I have a x equal to true and y equal to false. Remember that Python is a case sensitive language. So I've given x and y value. So now let's say x and y, it will give me a false, because if any of either two values, any of the value is a false, then in the end condition it always be a false. If I say x and y and run it, it will give me a true. So in or condition, if we have any value is a true, it will always give a true. So let's change some values over here and see what are the differences. So x, now I'm going to give the value x equal to true, y equal to true, sorry, yes, yeah, true, and then run x and y and see the value is coming as a true. So this is the way we are going to use the logical operators when we do a programming. So far we have learned how the variables are defined and work in the Python. The operators which we have, different operators we are going to use, we are using it, like arithmetic operators, relational operators, and the logical operators. So, and the data types. Oh, I forgot about to talk about the complex one. Okay, so maybe in your early classes like 7th, you have studied the complex value. So what exactly the complex value? Let me show you the example over here. So if I say my x equal to 3 and y equal to 4j, right? So 4j is my value, and if I write over here the type y, and see, this is give me a value as a complex over here, right? So this is the complex value, and how these are going to work in, let me show you. So if I say x plus 4j and run it, it will give me 3 plus 4j. The complex value and the integer value will be showing into this way if I'm going to use it. So later on in our course we are going to understand how the complex value use and we use to work on it. So let's move ahead and go to the next part, which is a data structure, and we are going to okay, before that we going to understand the tokens. So these are the tokens in the Python, the keywords, literals, operators, and identifier. So we are going to study all four of them tokens, and what are these keywords and literals and identifier operators we have already discussed. So let's go for a keyword first. Yeah. So basically, if we talk about the keywords, keywords are a predefined and reserved words in the Python which we are use, which they have a specific meaning into the programming language, and which we are going to use in our uh, programming and or whenever we are doing it, coding itself. So let's take a few examples of some of them. So you can see this is a table which is containing the key reserved keywords of the Python, like false, await, else, and all. So later on each stage we are going to use these keywords and see how these keywords are work and all. So let's take a few examples of these. So I'm going to take an example of let me take in a very simple example. Let me open one another notebook of open which I have opened over here. So I'll take an example of a break and continue. Let's take an example. So I'm creating, also I'm using a for loop into which we are going to study in the flow controls for a in range. So if you are not understanding what I am typing, just doesn't matter, because in further sessions we are going to study each and everything in a detail. So this is the range I have given over here. So this is the way we are writing a for loop. But in the flow control, we go through each and every flow control, how we are writing and understand each and every line statement meaning over there. So I'm writing where as a what I'm going to do. I'm going to print value of a, right? And this is my another statement which I'm giving, say if my value of a is less than 6, it will continue, else, in case else, break. So this is how I'm going to create my code over here, and let's run it. Okay, so there the problem is coming over here, that yeah, no, like I said, this is case sensitive, and yeah, these kind of small things we have to always remember that. So now you can see 1 2 3 4 5 6 value is showing over here as the output. The continue, this statement has been given over here. And let's take another example of we'll take an example, would say lambada. This is another one of the keyword. Let me show you in the keyword itself. So I have another, this one. So let's say I have a value of I equal to lambda j plus 1, and I give a for loop like a in range of 1 to 5, and now I'm going to print value of I and a. So this is my one, and let me run it. Let's see, it's giving me a value of, because this is showing me a value is wrong over here. And why it is, because I have given something wrong value over here. Let me see. Okay, my mistake, I have given this one. So basically you can see in this interpreter ID, we can check whether the keywords which we have used are correct or not. So you can see that before I have given the wrong spelling over here, that's why it's giving me error, invalid syntax. So let's run it again. Sorry. So let me copy this again, paste it over here, and now I'm going to run it. Now it's again showing me a value of is a wrong a. So let's see what is the problem I am having over here. Is it's again saying unexpected indent. That means somewhere I have again give a mistaken over here to do that. Let me check it. I equal to lambda. Let me do that. Now I in range 1 comma 5, print a I and run it again. Yeah. So basically this was a problem because I have the indent was correct, wrong. So these kind of silly mistakes we do that, but in the using Jupyter Notebook, we can come up with all these kind of mistakes over here. So you can see this is the way we are using the keyword. So let's take another example of another one which we are going to use. So let's take another keyword written over here. So we take the example of one. So there's another keyword is a def to define one. So let me do that. So I'm defining a function. The first, this is my function which I'm going to define. Return value is a, and let's talk about given value of x equal to fun. This is what I'm doing, calling it, and let me print the value of x. Now this is, so I have done the return, but before that I have to provide some value. So let me provide the value of a equal to 5, a equal to 5 over here, and let's run it again. See, you can see this is a problem of indent. Why it is? Because I have done a mistake doing this. If I'm going to run it, you can see 5. So always be a very careful whenever you are writing a code. So these kind of things we have to always remember. But the good thing is that if we do something wrong in kind of a syntax, it will provide a error, like indentation errors over here. So we can always rectify it. So in this way, so this is the way the keywords we are used. So you can see these kind of keywords, a lot of keywords like continue, when for loop, asserts, when true, none, false, await, else, import. So these are going to use when we going forward we study about the Python, and we uh, do programming into a Python itself. So these are some of the examples I have given. There are a lot of, so if else, these are for giving a if else condition. Else is kind of a else if condition. We have async, assert for check the values, global to define a variable on the global level. So these kind of keywords we are going to use it. The next thing is the literals. So basically literals are, we have a five types of literals we have: string literals, numeric literals, boolean literals, and we have a literal collections and the special literals. So we are going to study each and every literal and see some of the example of the literals. So the first question comes, what is the literals? So basically literals are a notation for representing a fixed value in source code. So that's why we use a literals itself. So let's take an example for each one. Well, first we talk about the literals, string literals. So in the string literals, if we're writing a text in a single quote or double quote or even a triple quotes, then it's become a string literal, and we use triple quotes to provide a multiple lines of strings into our programming language and the coding side. Then again we have a numeric literals, which are have three types of numerical literals: integer, float, complex. We have a boolean, which are true and false, and we have a literal collection like list, tuple, dictionary, set. And the fifth one is a spatial literal, which we talk about. So first we discuss about the string literals. What are actually the string literals? So let me go to my notebook. I'm going to create notebook over here. So let me close the previous one which I have open it. So so this is one I have. So now let's talk about the literals. So first of all we discuss about the string literals, how we use the string literals. So let me give a variable name a equal to, I'm going to single value is So this is the one I'm going to print. Okay, B, I'm going to value, you can see I'm giving to value in double quotes over here. I have a value C over here, in which I'm going to give the value tips and clicks. Now let's print value of A, sorry, print value of B, print value of C, and see what would be the result. So you can see all are coming in this the same way which we are written over here. So this is the way the string letters are work. And there is another called as a character literal, which is a part of a string literal itself. So it's about using a single character. So let me give an example of character literals also. So if I have, suppose x is my variable and I'm giving a value into this as q over here, and if I have another variable which is e, and I'm giving the value in the double quote as a t over here, and let me print the value of x over here and the value of print the value of e, and if I run it, so it's a q and t, you can see that. So this way the character literal will work. Now let's talk about our another literal, which is nu- numeric literals. So numeric literals we have three: integer, float, and complex. So we are taking the example of each one of them. First we'll see the numeric literals, and we see after that the float, and following with the complex one. So for let's talk about the integer first. So in the integer, it will consider the both values, positive and negative numbers, including the zero also. But in we have to remember that in this case we should not have a fraction part of the value. So let's take an example. Let me give you an example of. So I am going to write over here so you can remember what exactly we are. So we are using a binary literal first. So I have a equal to, let's say, 0 b f 0 1 0 1 0. This is the value which I am giving over here. Okay, so this is the value. Let's take a value of decimal. Decimal literal over here. Let me say b equal to, give a value of 60. Next example will take octal literal. So basically I am giving each and of every example over here to understand, you know, a different output of all of these. So this is my octal. Let's see, equal to 0 0 1 3 2 0. Let's take another example of the hexadecimal. Hexadecimal literal. Give me some space. Where the equal to 0 x 1 2 b. And let me change the value of this for some, otherwise it will give me a value 1 0 1 0 0. Yeah, that's right. Okay, so now I'm going to print the value of all of them. So I'm going to write a comma b comma c comma d, and we'll run it. So now you can see the value of 20 60 208 299. So what exactly in this case? So in the integer literals, we assign these value, which you can see I have assigned for A, B, C. So here is A is my binary literal, B is my decimal literal, C is my octal literal, and D is my hexadecimal literal. So but when we are using a print function to display the value or to get the output of this convert, so what it will do, it will convert it into a decimal and provide the values. So that's why we are getting, see the such values 20, 60, 208, and 2099. So let's take another example of a float which we talk about. So let me write it over here. Float literals. So my example is, let's, I'm going to continue. A equal to, take example of 3.32.1, B equal to 43.0, and let's print these values A comma B. So you can see the values coming into the letters in this format, because these are the floating point numbers over here. Now the third one, which we talk about, the complex literals. So let's take an example like we have shown you earlier. I have a variable called p equal to, let's say, 9 plus 6x. This is one of my, and I say k, let's say q equal to 4x. Yeah, now I'm going to print it over here. So z p comma q, and if I run it, okay, it's giving me an invalid index. Why is giving me an invalid index? Let me check. I have given a p, so let me do something R&D. Why it's giving me a value of wrong value? I have given a right the value it is. Let's run it again. Okay, and the line I have given x, so let me change the value of like, yeah, so you can see that it's giving me a 9 plus 6j plus 4j. So in this way we can use a complex literal over here. In this, if you can see, 9 is my real part, and 6j, which I have written, basically b, which is 6 part 6, it's my complex part. Now we talk about the boolean literals. So I am going to write over here boolean. So it's the same way, like if I say my let me say true. Now if I am going to write in this way, like you can see the color of true is different. Now if I say so if I say equal to 1 equal to false, see, now you can see the difference. If I'm writing a false in this way, it's giving me the color is different, it's in a black font. But if I change the value f in this way, it will, so it will show me that I'm doing some mistake over here using a proper keyword. So I have written over here. Let me now do that with a boolean literals, using a boolean literals. So I'm writing true plus 2. I'm writing b equal to false plus 5, and let's print the value of double quotes a is, and comma, we can see value of a. If we say print, we are, what we are doing, we are going to print all of the values, the values variables which we have. So b is b, And if we say print over here, C colon C, if we for the print D D colon space comma D. Now we are going to execute it, so let's execute. So again it's giving me error on this because I forget to use a comma. So let's do again. Now you can see A is true, B is false, C is true plus 2, which is a 3, and D equal to 5. So what exactly it is doing it? It's taking a value of true, 2 plus 1 is, you can see 2 plus 1 is 3, and this is the false, so it won't take a value of this. So D value is 5 over here. So you can understand in this way that when we talk about in Python, the true represent always a value as a 1 and false represent a value of 0. So that is the reason when we are using a true plus 2 is showing me a value as a 3, but in case when I'm using a false plus 5, it's giving a value of 5. So it's like 0 plus 5 and 1 plus 2. So that is the way, this is the way we are using a literals in our Python programming language. So for this part, we have so far we have covered three literals: string, numeric, and the boolean. In our next session, which we are going to cover is a little collections. What are the little collections? So let's take an example. I'm going to do that. So what I basically the little. So there are four little collections. One is a list, second is a tuple, third is a dictionary, and fourth is a set. So all of them have a different usage when we do programming. So let's go and discuss each and every collection literals in a detail. So first we talk about the list literals. So list contains item of different data types, and the values stored in a list are separated by comma and enclosed within the square bracket. So let's take an have an example and remember that the lists are mutable. So let me write it over here. The list literals. Okay. So I'm taking a name equal to given a name. So Amit so I have given a name in this way. So this is the name which I have given. Let's print these, print name, and run it. So you can see this is the way we are going to use a list literal. So same way we can use for a different data types also over there. Yeah. Now talk about the tuples one. So what are the tuples? See, tuples is a collection of a different data type. But when we talk about the list contains items of different data types, and the tuple is a collection of a different data type which is enclosed by a parenthesis, and each element is separated by comma. So let's see the example and remember that list is a mutable, but the tuple literals are immutable. So let's talk about the example of tuple. Like I have said, even number equal to 2 comma 4 comma 6 comma 8. If I say odd number equal to 1 comma 3 comma 5 comma 5 and 9. So this is, so now I have to print the value. I just write it down, even underscore number, and let's print it. So it's printed 2468. In the same way I can use that part also. Now let's talk about the third one, which is called a dictionary literals. So what is the dictionary literals? See, dictionary literals store the data in the key value pair. If you remember, if you know about the Java programming language, we have a collection, we use map to store the value in a key value pair. But we are using dictionary literals in Python to store the data in key value pairs. So it's basically enclosed by curly braces, and each pair is separated by a comma. And remember that dictionaries are mutable. So list and dictionaries are mutable, and the tuples are immutable. So let's take a look at the example of dictionary literals, how the dictionary literals work. So let me take an example of a student comma in underscore info. This is my variable. Now I am going to store the value in a way. So let me give an example of this. Name, I have, this is my key. I'm going to give the value. So give the name, colon, Shamsher, a comma. I have given the value of age over here, giving colon 40, comma. If I say state, state, I say value is UB. So this is, I have given a dictionary over here. So now let me place the value, which is print student underscore info, and let's see. So it's going to show me this one. This is the way. Now the last little which we need to talk about the little collections is the set literals. So what set is? See, set is the collection of unordered data set, and it's enclosed by the parent curly braces, and each element is separated by comma. So the example, so if you have a experience, if you have some experience, or you studied the Java or doing a programming in Java, so you might be thinking that is similar kind of which we are using collection into that. Yes, it is, but the way we are using it, it would be a different. And we, in the later sessions, in the later videos, we going to see how these things are going to use in a data manipulation, data storage in the programming itself, because it's all about playing with the data when we talk about doing a programming or a coding, right? So let's take an example of set literal. So set literals, oh my bad, let me click on this hash set literals. So let me type fruits over here, and I'm writing over here in the curly braces is apple, comma, this is a season of mango, so let's type a mangoes. Another one, grapes. Next one would be kiwi, right? So I have put it over here, so let's print fruits. So let's run it. So see, so this is the way we understand, we use the set literals over here. Now the last literal which we talk about is a spatial literal. So basically, in Python we contains a one special character which is a none, and basically none is used to define a null variable. If none is a compared with anything else other than a none, it will return a false. So we'll see the example of the spatial literal. So let's say this is what I am saying. Like suppose the food is remaining, I have given the value as a none over here. You can see this is the one, and if I can go over here and see into my keywords, now you can see this is my keyword none. This is also a keyword into. So Now if I'm going to print over here, food remain, click on this, now it's giving me an error over here, right? So why is giving me a error? Let's see. The food name food remain is not defined, right? So let me see what we have over here, and let's remove the problem which we have. Okay, because the spelling, let me do that. Okay, so this kind of a mistake, sometimes we all of do. So this is the way we are putting the values over here. So now so far we have learned the variables, the operators, three different types of operators, data types, five types of data types which we have. We studied the literals, and each one of the literals, type of literals we have, that we have already literals. In the next section we will study, further study the Python, which we have in our course, which is, so far we have studied till operators, tokens we have. So next in we going to study the data structures, flow controls, and the oops concept, and we'll go further. So if you like this video, please like and share, and if for channel support, please follow and share. Thank you very much. Thank you all.